So previously, we had talked about different types of functions, ones that maybe gave us lines or planes, and then we looked at some conic sections. So today we're going to talk about very nice types of functions, which are vectored value functions. And it's just what it stands for. A vector valued function is a function whose output is a vector. Now, we already had talked about a vector equation for a line, where I of t equals some initial point plus t times a direction vector. More generally, we'll have this form. R of t, the vector r, will be equal to f of t, g of t, and then h of t. Or if we want to write it with our standard unit vectors, we got f of t times I hat plus g of t times j hat plus h of t times k hat. Now, this input variable, which in this case we're using t, is called the parameter, where we vary t and we have our vector r. Since the r is a function, we can ask about its domain. What is the domain of this vector valued function, where r of t, the vector, is equal to the square root of 4 minus t squared, e to the minus 3t, and the last component is natural log of t plus 1. Well, we look at it at each of its components. If we look at the first one, we have the square root of 4 minus t squared. And we know that in order for this to be valid, 4 minus t squared has to be greater than or equal to 0. In other words, 4 has to be greater than or equal to t squared. And when is this true? That's when t is less than or equal to 2, or it is greater than negative 2. It has to be between there and there. Now, what is the domain of e to the minus 3t? Well, e can take any sort of input, so t has to be less than infinity and greater than negative infinity. That one was easy. The last one is what is the domain of natural log of t plus 1? Well, in order for this to be a valid function, we know that t plus 1 has to be greater than 0, because t of 0 is undefined. In other words, t needs to be greater than negative 1. We look at all these domains and we put them together. So we know that the domain of this function here is going to be t's that are greater than negative 1, but also less than or equal to 2. And that would be the domain of our function r of t.